calendar. Today's date is December 7th. We'll start off with our usual sort of pair and share. The question for today is pretty straightforward. I just threw it in the chat right now. What is your favorite TV show? And this could also be your favorite streaming show, right? I know not everyone watches TV, so this could be anything that has multiple episodes from Netflix, Hulu, HBO, Disney Plus, whatever you watch. Think about one that you feel like you've rewatched a few times, you find yourself quoting a lot or thinking about a lot, or just enjoy it. Think about that for like 20 seconds. And don't forget to say hi and check in with the person you're in the room with as well. We'll come back together in 2 minutes. Rooms are open. The docket then is homework check as usual. You just had to make sure that you completed the classwork, chiefly the formative assessment probe that we did in our previous lesson, and make sure you've submitted a photo of your notes from Hewitt chapter 27A, just a couple pages to read there, and then the quiz. Reading quiz is looking great. I'm seeing 14 attempts. I think everyone got 100%. So it looks like we're feeling good on that. Plus you had multiple attempts to give it a try. Main takeaway from that reading, I think, is just to understand that climate change is something that occurs naturally, right? Our planet has gone through several ice ages and changes in climate, but we are now seeing what are called anthropogenic effects, meaning like we as humans, like as a living species, are apparently accelerating the change in climate on our planet currently, which is kind of interesting. So, and that's something we're going to be exploring throughout this entire unit, especially in the next few lessons. So any questions or comments or anything you found challenging from that homework though? All right. Then as promised, the first thing we're going to do today is analyze the carbon footprint data that you guys submitted a survey of back in September. So you guys remember that long survey you did about like the light bulbs in your house and how much you traveled and the food you eat. So what I've done is compiled that data into a quiz, and I'll just show you really quickly what you'll be doing. So on the tasks to complete list, this is step number 3. You're going to click on that link there, carbon footprint data analysis. It'll take you to a reading quiz, or just a quiz that looks like this. And so just remember there are 4 categories, right? Transportation, home, food, and purchases. And basically it calculated your personal contribution. So like how many kilograms of carbon dioxide are you adding to the atmosphere through your living and your activities? Obviously this isn't 100% accurate, but it's just a rough guess. What I've done is compiled the data for each class. So you're going to need to open this Google sheet first. So open Science2B, this is B period. And then you should be able to find your name and your numbers. So these were your personal numbers from back in September when you took this. And then the first few questions, what I did was I calculated the average for all 3 of my classes. So I took all 3 sections, all the data, added it up, divided it. And so there's your average kilograms per student for transportation, for home, for food, and for purchases. And so what I'd like you to do is compare your number to the class average and just reflect a little bit about why your number might be higher or lower or the same. And then there's 2 graphs for you to consider. The first one, I took all the male students and all the female students and compared their average carbon footprints. So you'll see that data there, and you can kind of analyze that a bit and try to explain some of the differences. And then I also took all the data for students living in the United States and students living outside the United States to see the difference there. So I'm going to time for 15 minutes to work on that, but once it looks like everyone has that submitted and in, we'll come back together to review. So 15 minutes to work on carbon footprint data analysis. Let me know if you need help, if you're not sure what to do. All righty. So this was from the reading. I think the first ones, and carbon sources is kind of obvious. These are things that are releasing CO2 into the atmosphere. Not surprising, it's obviously burning coal in power plants, burning fuel in cars, that kind of thing. Carbon sinks, to me, is the kind of weird term, but what that's referring to, again, is anything that is removing carbon dioxide, putting it back into organic form. Trees are performing photosynthesis, and they're actually converting carbon dioxide into food. So believe it or not, the sugars you get in things like apples and other stuff like that C6H12O6, those 6 carbons actually come from carbon dioxide gas. So that's what you're eating. And then we release it, once we've digested it, we release it again as carbon dioxide. The oceans are actually absorbing a lot of carbon dioxide as well. This is what's causing what's called ocean acidification. Oceans are actually Ocean water is basic, but it's becoming less basic because there's so much carbon dioxide that has to seep into it now. And the big thing here, obviously, is that this was a well-balanced cycle until humans came along, and now we have had such an impact on this that we are drastically increasing the sources while simultaneously eliminating, right, cutting down forests, we're eliminating the sinks. And so that's another reason why we are starting to see this increase in atmospheric CO2. Now, I do want to emphasize this one point. Greenhouse gases are a natural and necessary thing, right? We need carbon dioxide in the atmosphere. We need methane. We need water vapor to trap solar radiation. Can anyone tell me what would conditions on Earth be like if we didn't have any greenhouse gases in our atmosphere?
Cold.
Yes, very, very cold. To the point where probably water would not be able to exist in liquid form. You would not see many forms of life being able to survive on our planet. So, when we say reduce carbon emissions, we're not saying that we need to completely remove carbon dioxide from the atmosphere. That would destroy the planet. But we need to get it back down to a more balanced level because all these gases are very important for trapping that solar radiation that allows for warmth on the surface of our planet, for water to exist in liquid form, and for life to exist. So in terms of how this works, this is what I think is kind of interesting if you want to get into some of the chemistry behind this. You can measure the potential that different gases have to capture and re-release solar radiation. It's called the global warming potential. And interestingly, according to this graph, if you can see here, carbon dioxide is actually very low. Has a level of 1, but there's just so much of it that it has a pretty big impact. Whereas again, as I mentioned with the refrigerators, fluorinated gases, this is what's in your refrigerators, hugely adept at capturing solar radiation. So we don't want a lot of these in our atmosphere because it's just a little too powerful. Also, these aren't exactly things that would exist in nature. These are very much human-made, whereas carbon dioxide is a natural thing. In terms of how this actually works, carbon dioxide, CO2, actually looks like this. It's an oxygen double bonded to a carbon, double bonded to another oxygen. And they, as solar radiation comes in and strikes these molecules, it's like a spring. The oxygen and the carbon spring back and forth like a slinky. And it's that energy then that can then trap and re-release that solar radiation later on. And that's just how these molecules, and methane behaves in a similar way, that's how they're actually capturing the heat in our atmosphere. And you can read more about that if you want. There's some pretty good videos, but that's how it works. And so that's important, right? We want some warmth to be trapped in our atmosphere, but the problem is that if we start to drastically increase CO2 levels, which is what we're now seeing, it's going to have negative effects. Okay, in the interest of time, I'm going to stop there. We will pick up where we left off next time. Questions or comments on that? All right, kids, homework is the usual deal. You're going to be reading a chapter in Hewitt and submitting notes and answering questions on a quiz. It is going to be a jump into a completely different chapter. You're going to be reading about the human circulatory system. That's not a mistake. I know it seems a little jarring, but the next step in our look at the atmosphere is how we interact with it, specifically breathing. But if you're going to understand the respiratory system and how we breathe, you've got to understand what's going on with the circulatory system first. So that's why we're starting there, and we'll use that to step into respiration. So that's why you have that reading. That's it. Thank you very much, kids. Hope you have a good rest of your day.
Thank you.
Bye.